Earth Systems 3209. Unit 4, the forces within Earth. References for this unit can be found in Chapters 4, 15, 16, and 19 of the textbook, and also can be found in Appendix A and Appendix B of the curriculum guide. Unit 4, Topic 2.6. This topic will look at plate boundaries, and in particular, the convergent plate boundary. It will focus on describing and giving examples of 3 types of collision boundaries, and demonstrating through a drawing the processes associated with convergence, plate convergence. When we look at plate boundaries, according to the plate tectonic theory, there are 3 different boundaries that exist at the edges of tectonic plates. Number 1, a divergent boundary, which is also called a ridge. Number 2, a convergent boundary, which is also called a trench. And number 3, a transform boundary. Information on these different types of plate boundaries can be found in the textbook on pages 526 to 539, and you should refer to Figure 1917 on page 528 to see the location of these types of boundaries on the world map. Let's first look at the convergent type plate boundary. Convergent boundaries exist in 3 types. The first type of convergent boundary exists where you have ocean crust colliding with ocean crust. These ocean-ocean convergent boundaries are formed when you have 2 oceanic plates colliding together. Compressional forces are the main types of forces which cause oceanic plates to move together, causing one slab of the lithosphere to be consumed into the mantle, initiating volcanic activity, which creates volcanoes to form on the ocean floor. The volcanoes produced at this collision boundary are island arc volcanoes. They form a curved arc on the surface when you take a map view that is an overhead view. Features called ocean trenches are formed at these types of boundaries. So if we look at the diagram to the right, we can see that we have ocean crust colliding with ocean crust. The neighboring continental crust is located many kilometers away, maybe up to hundreds of kilometers away. One of the ocean crust oceanic plates will actually subduct down into the mantle. Once it subducts down, it tends to melt, and this molten material will rise up through the overriding plate, where it breaks through the surface and it forms what's called volcanic islands. These volcanic islands that are located several kilometers or several hundred kilometers off the continental coastline forms a linear arc of volcanoes. And this linear arc of volcanoes is what's called a volcanic island arc. So volcanic island arcs is a predominant feature seen through ocean-ocean collision boundaries. The composition of the molten material is largely andesitic, which is intermediate in composition, since the melting basaltic mafic oceanic crust becomes mixed with melting sediments that were located on top of the subducting plate as a result of weathering and erosion from the nearest continent, which is generally felsic in nature. Lithosphere is destroyed as one oceanic slab descends beneath another. An example where you see this type of boundary would be off the coastline of Asia along the Japanese islands. The Japanese island arc is a series of Japanese volcanic islands that are located off the coastline of Asia. And off the coast a little farther out, we would find the Japanese Trench. That's where the Pacific Plate subducts down beneath the oceanic floor off the coast of Asia. So if we refer to the diagram above, we would notice that we have volcanic island arcs, and these off the coast of Asia would be called the Japanese islands. The second type of convergent plate boundary is an ocean-continent convergent plate boundary. Ocean-continent collisions involve an oceanic plate colliding with a continental plate. Here, compressional forces cause the ocean plate, which is more dense, to subduct and move underneath a continental plate. As the ocean plate and continental plate move together, the oceanic plate tends to subduct beneath because it has a greater density. The oceanic plate will most likely subduct beneath the continent and will result in the formation of a trench and a subduction zone located off the coast. In a map view that's looking downward, volcanic arc is created on the continent as a result of the collision. And the lithosphere at a collision boundary such as an ocean-continent collision boundary would be destroyed as one oceanic slab descends beneath the continental crust. In the diagram to the right, we have oceanic crust subducting beneath continental crust. Once the oceanic crust descends, it melts. The molten material will slowly migrate upwards because it's less buoyant, or more buoyant, and less dense than the surrounding rock. This hot molten material, when it breaks through the surface of the continental crust, will form volcanic arcs. And a volcanic arc, when you look from above a map view, we will see a linear line of volcanoes extending down the coastline of the continent. And this is what's referred to as a volcanic arc. The composition of the molten material at an ocean-continental convergent boundary is most likely to be granitic, since the upwelling magma created by the melting ocean crust has to burn through granitic rock that's located within the continent. At depths of about 100 kilometers, the ocean plate and parts of the mantle partially melt, producing viscous magmas. This molten rock rises where it cools and solidifies at depths, producing plutons. However, some magma may reach the surface where it erupts through the surface to form composite volcanoes as violent volcanic eruptions. An example of this type of activity is seen along the ocean-continent convergent boundary located on the west coast of North America along the Rocky Mountains, and also in the Andes Mountains, which is located on the western portion of South America. Both the Rocky Mountains and the Andes Mountains result when the ocean floor, Pacific Ocean floor, subducts beneath each of the two continents, North America and South America. So in the diagram to the right, we see that we have the ocean floor subducting beneath the continental crust. If this continental crust was North America, then the volcanic arc would stretch down along the Rocky Mountains. If the continental crust represents South America, then the volcanic islands, the volcanic mountains, would stretch down along the Andes Mountains in South America. You should also note that at convergent boundaries, both convergent boundaries show the destruction of oceanic crust. Therefore, lithosphere is being destroyed as compressional forces cause the two plates to collide, which forms mountains, which are a predominant feature at collision boundaries. A third type of convergent boundary will be continent-continent convergent boundaries. The continent-continent collisions involve two continental plates. Compressional forces cause the two continental plates to move toward one another where they eventually collide. Once the oceanic crust between the two continental plates have been entirely subducted and the continental shelves have nearly joined, the process of subduction ceases. Lithosphere at this type of boundary is destroyed as the oceanic slab descends beneath another. Because of the low density of the continental crust, neither plate will subduct once the two continents collide with one another. And as a result, both continental shelves get uplifted and deformed, forming folded mountains. Such collisions occurred when India collided with Asia, forming the Himalayan mountains. and also during the formation of the Appalachian Mountains some 500 million years ago. Global examples of continental-continental collisions include the Himalayan Mountains, that's presently forming when India collides with the southern portion of Asia, and also in the geologic past, the Appalachian Mountains was a direct result of continent-continent collisions. So the Himalayan Mountains and the Appalachian Mountains are two such examples of continent-continent convergence. When we look at the diagram to the right, you'll notice that the oceanic lithosphere that was once in between both continents is fully subducted and destroyed. And as a result, one continental crust will collide with the other continental crust. And these continent-continent collisions form the highest mountains that are known to have existed. Presently, India, which is colliding with Asia, is forming the Himalayan Mountains, which have the highest mountain peak in the world, which would be Mount Everest. So along these types of collision boundaries, we see very high mountains forming, and they result by compressional forces causing two continental plates to collide with one another. When we look at the different types of plate boundaries, we have three different types of plate boundaries which are located along the edges of tectonic plates. We can have divergent boundaries, convergent boundaries, which is the focus of this lesson, and transform boundaries. The motion along the divergent boundary would be spreading. That's where two ocean crosses are actually moving apart from one another, which is caused by tensional forces. We can have subduction zones forming, and a convergent boundary. That's where two tectonic plates collide with one another, which is caused by compression forces. Or we can have lateral sliding, which is seen along transform plate boundaries, where two plates slide past one another, caused by shearing forces. The different effects would be along the divergent boundary. We see constructive plate boundaries. This is where ocean lithosphere is being created along a ridge. At convergent boundaries, we see destructive forces, where ocean lithosphere is being destroyed as one plate is subducted down into the mantle at a subduction zone. And at a transform boundary, we see conservative forces. Lithosphere is neither created or destroyed as one plate slides past one another. At divergent boundaries, we generally see ridges or rift valleys forming on the surface. Convergent plate boundaries, we see the formation of trenches and often volcanic activity. And along transform boundaries, we generally don't see any dominant feature on the surface, just a fault that runs along the length of the transform boundary. At this point, we should note that at divergent boundaries, we do see volcanic activity, but we lack earthquake activity. At convergent boundaries, we do see volcanic activity, and we also see earthquake activity. Earthquake activity can be found in the shallow subduction zone, which is called a shallow focus earthquake, moderate focus earthquakes in the upper mantle, and deep focus earthquakes in the deep mantle. At transform boundaries, we don't see any volcanic activity, but we do see earthquake activity. And the earthquake activity will occur near the surface along the transform boundary, and these are called shallow focus earthquakes. Let's look at some past questions on past public exams. First question reads, collision at which boundary would result in the tallest mountains? So when we look at the three different collision boundaries, ocean-ocean, ocean-continent, and continent-continent, each of the collision boundaries will have different surface features. Ocean-ocean collisions will produce island arcs that are found on the ocean floor. Ocean-continent will produce volcanic arcs, which are volcanoes located on continental crust. And continent-continent collisions generally form very high mountains when the two continents collide. So the answer to this question will be D. Continent-continent collisions would result in the tallest mountains being formed. Second question reads, which is associated with an ocean-to-ocean collision boundary? As previously mentioned in the question above, folded mountains generally form along continent-continent collisions, but also can form along ocean-continent collisions. Mid-oceanic ridges is a feature formed at divergent boundaries. Island arcs would be your best answer here, because at a ocean-ocean collision boundary where one ocean floor is being subducted beneath the other, the result would be magma burning its way up through and forming a series of islands, volcanic islands, located off the coastline of the continents, and this would form what is called an island arc. So your answer to this question will be B, island arc. Example number 2 reads, based on the diagram below, which type of plate collision formed the Himalaya mountain chain? So if we look at it to the right, we see the Himalayan mountain chain located where we see continental crust clotting with continental crust. And as a result, the continental shelves would be sandwiched in between the two collision plates, resulting in a very high mountain chain being formed. These folded, deformed mountains would form very high mountains, as you see in the Himalayan mountains today, on the southern part of Asia. So the answer to this question would be A, continent-continent collisions would be responsible for forming the Himalayan mountains. Your turn. Take the time to complete the following questions. You can pause your recording now to prepare your answer, and the solution will follow. Question reads, a range of mountains is found on Australia's east coast. With reference to plate boundaries, explain how this mountain range may have been formed. So when you read the question carefully, it asks you to reference plate boundaries and explain how the mountain range may form. So when we look at the formation of mountains, we are looking at a collision boundary, a convergent plate boundary. So that must be included in your answer when you describe how a mountain chain or a mountain range would form. So when we look at the answer, we can see that mountain ranges are found along convergent plate boundaries. So here we refer to the type of boundary. So mountain ranges are found along convergent plate boundaries. At these boundaries, one tectonic plate moves toward and collides with the other plate boundary, generally by compression forces. In the diagram to the right, an oceanic plate, which is the Pacific plate, collides with a continental plate, which is the Australian plate. This collision causes the ocean plate to subduct beneath the continental plate. These compressional forces generally deform the tectonic plates, which result in the continental plate uplifting to form a mountain chain along the length of the convergent boundary. So this answer would be one of the possible answers to explain why you find mountain ranges along the edges of continents. Some extra practice problems are listed below. You can read through, and the answers are outlined in red. In summary, when we look at convergent plate boundaries, we generally find 3 different types of convergent boundaries, and they result from the collision of the 2 different types of tectonic plates. First example would be an ocean plate colliding with ocean plate. This would be called ocean-ocean convergence, and they generally form volcanic island arcs off the coast of the continents. The second type of convergent boundary would be an ocean-continent convergent boundary. In this type of boundary, we have ocean crust colliding with continental crust, and as a result, the ocean crust subducts beneath the continental crust because it's more dense, and it forms volcanic arcs, which are volcanoes found on the continents, and they extend along the entire length of the coastline of the continents. Our third type of convergent boundary will be a continent-continent convergent boundary. Along a continent-continent convergent boundary, we find the tallest mountain chains being formed. Some examples of these mountains would be the Himalayan mountains that are presently forming north of India, where India collided with the southern part of Asia, and also in the past, approximately 500 million years ago, when continents collided to form the Appalachian Mountains. All three types of convergent boundaries would experience compressional forces and also experience the destruction of the lithosphere. So these points are the main points seen along the three different types of convergent boundaries: ocean-ocean convergence, ocean-continent convergence, and continent-continent convergence. You should know how to recognize these three different diagrams for when you answer questions on your exam.